right. So, what you guys missed is that we did a warm-up, and we're on the back side here of the notes from 4.1. And we've got scores from 1 to 5, from shy to outgoing. And I had everybody in here list their 5 people that they feel closest to or close to, not necessarily closest to. And then I had them rate next to each one of their names how outgoing they thought that person was, from shy to outgoing. And then we put the percentages on here. So it seems like this class prefers, or it just happens to have people in their life that they love that are around that 3 to 4 range. Just a few down here in the really shy range, but, and that's just what we've gravitated towards, or what our families are, because frankly, you love your family, but you don't get to pick them. That's how that goes. So here we're going to make this x. This is going to be probability of x. Okay, so remind me how to find a weighted mean. For a prize, sure. I've got things over there, sharks it seems, and eyeballs, and mustaches, and I'm a winner signs. Emma?
You take like the x times the probability,
Uh-huh.
and then you add them all together.
Right, and then you add them all together, and that's going to be your weighted mean. All right, Caitlin, well, I'm not going to make you do this. 1 times 0.03 is 0.03, guys. I was supposed to say, let's go around the room and have everybody do it, but this is not too challenging.
Wouldn't the 4 and 3, would those be different for like the 0.29?
You're absolutely right. Who said that, Rihanna? Emma. Okay, well, that's 2 prizes for you, Emma. For fixing a mistake of mine, because I am sleepy this morning, but also for talking about the problem in the first place. Thank you. All right, you guys get 3.46 here? Yeah? So almost 3.5 apparently is our average score. Does that make sense to you? Looking at this data, does it look like, okay, about 3.5 is how people are? All right, so we're going to say mu is 3.46. And actually, for the next part, just so that it gets easier, we're going to make mu a solid 3.5, just for all of this stuff. So here's how you find the variance and the standard deviation of a discrete random variable for a probability distribution. It's the standard procedure as before, x minus mu, then we're going to take x minus mu and square it to get rid of all those negatives, and then what do you think? What'd you say? Well, that will be at the end, but we've got one more column that we're going to do before we get there. We've got to take into account the probabilities, right? Because each one shouldn't be weighted the same. It's kind of like a weighted standard deviation. Like, for example, look at this. I feel like we should give 4s more weight than 1s, right? Because we had way more 4s than we had 1s. So what should I write over here to account for that? Yes, times the probability of x. All right, now, this is important. Don't get off base here. You've got to use this x column, this first column, not your probability, x minus mu. So that would be what, negative 2.5 for the first one? negative 1.5 for the next, negative 0.5, positive 0.5, positive 1.5. Does everybody understand where I'm getting those numbers? Okay. Caitlin, you got this one. Let's have Sierra do this one. Jesselyn here, Natalie there. Emma and Thomas, Rihanna, and I'll do the rest. What would you guys guess is the deviation? Before we even do figure this out, what would you guess is the deviation around 3.5? How far do we vary from 3.5 on average? Maybe half, maybe one. You got here fast. Yes. How far away from school do you live? Okay. Still impressive.
That like teacher of the year award you got, is that like within the school?
Yeah, it's the secondary teacher of the year award. That means that out of like all the middle school and high school educators, I was the teacher of the year. And then they have one for like the elementary school. Because it's kind of hard to compare. They're very different professions. But yeah, it was a big surprise. I never feel like the best at anything, so it's nice to have people be kind about it. Okay. Caitlin, what'd you get?
6.29.
Sierra?
0.1874.
Jesselyn?
2.65.
Natalie?
0.45.
Emma?
42.